down to. Shawty, if you down, I'm down to. Yeah, I found you.
Hello, my dear students. Welcome to classroom. So, I hope you're all doing well. Once again, so happy to meet you all. I got. Another new song. The name of the song is Unforgettable, sung by PNB Rock. It's a good song. Alright, so that is it. Thank you. Whew. Now let us get serious and let us start the topic. Okay, so once again, I welcome you all, my dear students. My name is Benathang Paton, and I welcome you to the channel Classroom, where we learn together. So this is the last topic for the chapter. Okay, chapter 3, metals and non-metals. We are left with corrosion and prevention of corrosion. So this video may be a little lengthy, but then it's going to be very helpful to you, because if you ask me, I should say that there are MCQs which come from this topic. Okay, prevention of corrosion. This topic is very important. This particular page is very important. If you have your textbook with you, you can go and flip the textbook. Okay, I do not recollect the page number, but then it is very important. Okay, so you should study this thoroughly. You should study this particular page. Okay, is very important. But before we go into that, okay, we'll first start with this topic, which is called corrosion. So grab your notebook, grab a pen or a pencil, and start taking down notes. Okay, because notes are very important, and as a student you should have complete set of notes. Okay, that's what I tell you, my dear students. So maintain notes. Okay, notes are going to be helpful in exam. You are going to write notes only. Listen to the video, watch the video, understand, okay, and then learn the concept, and then learn the topics thoroughly. Okay, that's my sincere and my most valuable suggestion to you. So let's get with the lesson, my dear students. So let's first define corrosion. So let's define corrosion. So corrosion, C-O-R-R-O-S-I-O-N. I always thought that the spelling of corrosion is C-O-R-O-S-S-I-O-N. Okay, it's only today that I realized that the spelling of corrosion is C-O-R-R-O-S-I-O-N. Okay, I again thought that there was double S. Okay, so I am very weak with spellings. Okay, so please don't mind with that. So let's define corrosion. So what is corrosion? The conversion of a metal to its oxide. Okay, oxide, sulfide, and carbonate form is known as C-O-R-R-O-S-I-O-N. Since I have been corrected, I have to make sure that I don't make the mistake. So my dear students, this is the definition of corrosion: the conversion of a metal, okay, to its oxide. Remember, oxide number 1, sulfide number 2, and carbonate form number 3. So whenever a metal is converted to its oxide, sulfide, or its carbonate form, we will say that corrosion has taken place. Okay, so this is the most complete definition of corrosion, if you ask me, because I have also been a student, and then I have studied the different definition of corrosion, but then none of them, if you ask me, okay, I'm just sharing my opinion, none of them makes complete sense like this definition. Okay, with other definition I always forgot what is going on, because every new teacher gives me a new definition, so it was very confusing for me. But then the day I got this definition, I have always been referring to this, and I've always clinged to this definition of corrosion. So corrosion simply is the conversion of a metal to its oxide form, or its carbonate form, or its sulfide form. There are only these three. Okay, these three options are available. So whenever a metal is converted to its oxide, carbonate, or sulfide, then we will say corrosion has taken place. Okay, so remember this. So we will study them in detail one by one, but see some more things to help you build a concept. So we have a metal. Okay, we have a metal. So this is a metal. Okay, and this metal is surrounded by an atmosphere. Okay, this illustration is good. Okay, it's going to help you build a strong picture on what it is. So these are atmospheric gases. Atmospheric gases. So these kind of side notes are very important for you, my dear students. You should always draw these things, okay, on the rough, and then refer to this. So atmospheric gases, we can, let's say, oxygen. Okay, and this is a metal. Now we know that metal has a property to lose electron. So metals will lose electron. So this will lose electron. It will lose electron. And then non-metals, these are non-metal. This is oxygen, isn't oxygen. So non-metal, we know they receive electron, they gain electron. So there will be a reaction between this metal and this non-metal oxygen. Okay, so a reaction will take place. So a reaction will take place. Okay, a reaction will take place. Okay, and this reaction is what we are going to study today. This is called corrosion. This reaction, CORROSION. Okay, this is what corrosion is. It is a reaction between a metal, okay, with with oxygen, is it not? So basically, a metal reacting with oxygen means oxide. So this metal is converted into oxide form. Okay, so metal reacting with oxygen, oxide. Metal reacting with carbon dioxide, carbonate. Metal reacting with sulfur or sulfide. Okay, so it will be sulfide, or it will be its sulfide form. So this is what we are going to study today. Okay, so corrosion. Okay, so basically here, okay, this should serve as a good explanation to what we are going to study today. Okay, a given metal, okay, metal lose electron. So metal will lose electron. This is a non-metal surrounding the metal. So this non-metal will come to receive the electron which is lost by this metal. So thereby a reaction will take place. A reaction will take place between the non-metal and the metal, between oxygen and this metal. That is what is called corrosion. Okay, this is what we are going to study. Okay, so let's study the different types of corrosion one by one. Okay, so the next topic is types of corrosion. Types of corrosion, CORROSION. So the first type of corrosion that we will be studying is a very common type of corrosion which we experience, okay, every day, which we have seen in and around us, and I'm sure, I can guarantee you that you have also seen that, okay, happening around your house or in your locality. First one, rusting. Okay, rusting of which metal undergoes rusting, my dear students? Please tell me which metal undergoes rusting. Yes, it's iron. Rusting of iron. Okay, so let's study this one. Number one. So the first thing is, we'll define rusting. So how does rust actually take place? How does rust take place? So when iron reacts, let me erase this one. When iron reacts with moisture and oxygen present in air, okay, when iron reacts with moisture and oxygen present in air, ferric oxide is formed. Ferric oxide is formed. Ferric oxide is formed. Okay, this is called rusting. Remember this, my dear students. What is rusting? So rusting is when iron reacts with moisture and oxygen, okay, present in the atmosphere, and forms ferric oxide. This is called rusting. Okay, so there is a chemical reaction involved. So let us write down the chemical reaction also. So the reaction will be iron plus oxygen plus water. Remember here, Okay, moisture means water. Okay, the air has water in it. Okay, so moisture. And then oxygen is air. Okay, so what you get? You will get ferric oxide. So it will be Fe2O3.H2O. This is ferric oxide, which is our rust. Okay, so this is how rust is formed. Okay, this is how rusting takes place. So we have the metal with us. This is the metal we have. This is iron. This is iron. This is iron. Okay, the loha. Okay, in Nakamis is called loha. So iron is here. Okay, then iron, when it's exposed to moisture and oxygen, okay, what happens? Ferric oxide is formed. Okay, this is called rust. Okay, this is called rust. So basically this gets accumulated on the surface of the iron. So this is the iron, let's say. So what happens is that it gets accumulated on the surface. Okay, it gets accumulated on the surface. Okay, and then what happens? This surface will become reddish brown, is it not? Now this will become reddish brown. Rust is reddish brown only. Okay, this is the color of rust, reddish brown. This is the color of rust, COLOR, color of rust. So the color of rust is reddish brown. What is the color of iron, my dear students? Anybody who can tell me what is the color of iron? The color of pure iron, okay, before it undergoes rusting, okay, when it's being made in the factory, the color is grayish. Okay, it has got its metallic luster, which is almost grayish. Okay, so it will have its own metallic shine. So it has got this metal luster, metallic color. We can say metallic color, or we can say grayish. Okay, you go and visit the hardware shop, you will see steel rods. Okay, steel rods are made from iron only, so you will see the color. Okay, that is how unrusted iron looks like. But when the same steel rod undergoes corrosion, then the color will change to reddish brown. Okay, and this gets accumulated on the surface, and then what happens? This deteriorates the quality of the steel rod. Okay, this deteriorates the quality of the metal, and what happens? This rust gets to peel off. Okay, it peels off. Okay, if you hit it, it will peel off again. It will fall down again. Okay, it will fall down as crumbs or powder. Okay, so you hit it again after some time. Okay, you might have removed the rust, but again after a day or two, again if you keep it same there, again new layer of rust will develop. So eventually what happens? A time will come when the whole metal will get deteriorated, and then it will be broken away. Okay, so it's useless. Okay, rusting of iron is bad. Okay, we don't want rusting. We don't want rusted iron. There is no use for rusted iron. Okay, it's of no use to us. So we should prevent rusting. We'll be discussing about ways to prevent rusting much later also in the same video. Okay, so this is the chemical reaction for rusting. Okay, and you have to remember the factors responsible for rusting. So remember, there are two factors which are very much responsible for rusting. Factors responsible for rust. So this demonstration has been done in your textbook. Okay, in your textbook there is an experiment conducted with 3 test tubes: test tube A, test tube B, test tube C. Okay, if you study the activity there, the conclusion has been very clear. So the conclusion is that the factors responsible for rust, there are only 2 factors responsible for rust. What are they? They are oxygen and water. So point number 1, water. Okay, point number 1, water, and point number 2 is oxygen. So remember this. Okay, these are the 2 factors responsible for rust. Alright, so if you want to prevent rusting of iron, protect your iron from these 2. Okay, then your steel iron will be safe and sound for a long period of time. Okay, so next we will go for carbonate. We'll go for carbonate. So let's go for the second type of rusting, which is, sorry, not rusting, corrosion. Okay, the second type of corrosion. The next one will be tarnishing of copper. So we'll study how copper gets corroded. Point number 1 is done. Now point number 2. Point number 2 is tarnishing of copper. So this is point number 2. Okay, so what is tarnishing of copper? So basically it's asking what is corrosion of copper, or how copper gets corroded. So let's write down the process. So copper reacts with moist carbon dioxide present in air to form basic, or we can even say the color, to form a green layer of copper carbonate. So this is what is tarnishing of copper, or how copper undergoes corrosion. Okay, so copper reacts with moist carbon dioxide present in air to form a green layer of copper carbonate. Okay, so let's write down the definition. The definition is written. Let's write down the chemical reaction involved in this. For every type of corrosion, you have their specific chemical reactions. Okay, so you have to remember those chemical reactions also. So we have copper. So the formula of copper. What is the formula of copper, my dear students? Anyone who can tell me the formula of copper? Copper, Cu. Yes. So Cu plus, now copper reacts with moist. Every time you hear the word moist means it's water. So plus H2O. Okay, it doesn't matter which is first or second. Okay, just write it. And then we have carbon dioxide. CO2 is here, is it not? It's not moist. After that, carbon dioxide formula is CO2. We all know that. Okay, and then present in air. Air means oxygen. So see, we have our copper, our water, our carbon dioxide, and our oxygen. If you're wondering how so much, it's from the definition. Okay, it's just from the definition. See, we have moist for water. We are talking about copper. So copper yahan pe hai. Carbon dioxide is there, and then air means oxygen. Okay, so air is oxygen only. So what you will get? You will get the product, which is CuCO3.CuOH2. Okay, this is your basic copper carbonate. This is your basic copper carbonate. This is basic copper carbonate, and what the color of this is green. This is green in color, greenish in color. Okay, so copper, if you ask me what is the original color of copper, you already know what is the original color of copper. Okay, go and check light wires. What color will the light wires be? Now why am I telling you to go and check light wires? Because I'm not telling you to go and touch light wire. Okay, that is going to be very little to you. Just see, okay, what light wires are made up of inside that protective casing. It will be copper wires only. Okay, copper wires. So the color of copper is brown. Okay, copper has its original color, which is brownish. Okay, so it has got a shiny reddish, it has got a shiny brownish color. So copper it's got a shine. Okay, so brown, reddish brown. So shiny brown, it has got its color, shiny brown. Now this shiny brown, okay, undergoes corrosion, and then the color changes to green. All right, so shiny brown color changes to green. So when copper undergoes corrosion, the color of the copper changes to green. Now I would like to give a very common example here, which you will never forget. If I mention the example, I can guarantee you that you will remember this. Okay, the next time if anybody asks you how copper undergoes corrosion, this example you will always remember. The example that I'm gonna use is the Statue of Liberty. So the Statue of Liberty, the Statue of Liberty, the Statue of Liberty. Do you know where the Statue of Liberty is located at? Where is the Statue of Liberty located? Class, where is the Statue of Liberty located? Yes, it's located in the United States, USA. Okay, United States of America. Now, whether you know or not, but then the Statue of Liberty was gifted by the French to the US. Okay, and then originally, now if you do Google checking also, you will find it that the Statue of Liberty was made from copper. So the French handed the Statue of Liberty to the US, okay, and the Statue of Liberty was originally made in copper, okay. But now, if you see the photographic images of the Statue of Liberty, what color is the Statue of Liberty now? It's almost greenish, isn't it? It's green in color. So copper has changed to green. The color of copper, which is shiny brown, has changed to green. So what does it mean? It means that the Statue of Liberty has undergone corrosion. Since the Statue of Liberty was made from copper, so now being exposed to carbon dioxide from the pollution, carbon dioxide from our breathe out, then oxygen, moisture. So okay, copper has undergone, the Statue of Liberty has undergone corrosion, and the present color of the Statue of Liberty is green. So that is a good example, okay, which you should remember, okay, to understand corrosion of copper. Now, in the previous example, it was rusting. This is tarnishing. Now, remember this, okay, between rusting and tarnishing, tarnishing is good. Now, why so? Okay, why is tarnishing better than rusting? See, both are corrosion only, but then at least in tarnishing, what happens is that, well, the metal is protected. So this is the metal, okay, let's say this is the copper. Now, when copper reacts with water, moisture, carbon dioxide and oxygen, what will happen? Okay, a layer will be formed, okay. This will be the basic copper, this is the basic copper, this one, basic copper carbonate. So the basic copper carbonate is formed here, so a layer is formed, basic copper carbonate, okay. Now this layer, this is your basic copper carbonate, so this is your CuCO3.CuOH2. So this is the basic copper carbonate which is formed on the surface of copper. Now this basic copper carbonate does not peel off, unlike rust, okay. Rust, okay, it will peel off, it will fall down, it will scrape off, but copper carbonate does not peel off, it remains, okay, it remains stuck to the copper. So what happens? This layer now acts as a protective shield, okay, and protects this inner copper. So the inside is still copper, okay. So this is why tarnishing is much better than rusting, because in rusting there is total deterioration of the metal, okay. In rusting the metal becomes useless, but in tarnishing, okay, in tarnishing not so like that, okay. The turn of even, the play of events are very different. In tarnishing, the inside metal is still copper, and it is, okay, only the outer layer, okay, has changed to this greenish coating, okay, which is basic copper carbonate, okay. So this is tarnishing, okay, and tarnishing is not so bad, okay, compared to rusting. So this is the tarnishing of copper, that is the second point. And now we have one more point, which is tarnishing of silver. So both copper and silver, they undergo tarnishing, okay. Point number 3, tarnishing of silver. Now we'll study tarnishing of silver. So tarnishing of silver. Point number 3, tarnishing of silver. Now silver is a precious metal, okay. We wear silver ornaments, but unfortunately the silver ornaments that we wear, it may be a necklace, it may be a ring, in due course of time it develops a blackish, the silver color fades away, and then it is replaced by a dull blackish color, okay. So which means corrosion has taken place. So let's define, okay, let's define how silver undergoes corrosion. So tarnishing of silver. So silver reacts with hydrogen sulfide, gas present in air to form a black layer of silver sulfide. So my dear students, this is tarnishing of silver. So silver reacts with hydrogen sulfide present in air, okay, air means oxygen, to form a black layer of silver sulfide. So a blackish layer is formed, which is silver sulfide. Okay, so let's write down the chemical reaction involved in this one. So we have our silver, which is Ag, plus hydrogen silver sulfide will be H2S, which is present in oxygen, air, so O2. So what you will get? You will get silver sulfide, which is Ag2S plus 2 molecules of water. Alright, so this is the chemical reaction, okay, involved in tarnishing, in corrosion of silver. So this is your silver sulfide, which is black in color, and this is why corroded silver items, they lose their silvery shine and then they are replaced by this dull black color. Okay, so this is tarnishing of iron. So like this, okay, for copper and silver they undergo tarnishing, whereas for iron, okay, for iron it is rusting. So these are the three types of corrosion which is shown by iron, silver and copper. Okay, now in the next we will be studying the preventive measures for corrosion. Okay, so how to prevent corrosion, for which I'll have to draw a table. So let me draw the table and we'll resume, and I'll start discussing after the table is drawn. Prevention of corrosion. My dear students, we will be studying three methods of prevention of corrosion. The first one is barrier protection, the second one is sacrificial protection, and the third one is alloying. Okay, we'll go into detail what each are. So I've already drawn the table here, so let me just go through and explain to you, okay, what they mean. So we'll start with barrier protection. Okay, as the name suggests, a barrier. So what is a barrier? A block, okay, a wall between two things. Okay, barrier. A wall is a barrier between the other side and this side, isn't it? So how is it done? How is barrier protection done? By applying a layer of paint, oil, grease, etc. So to explain to you in simple term, let's suppose that this is the iron. Okay, this is the metal. So what I do is I apply a layer of paint. I apply a layer of paint over it, or say I apply a layer of oil, or I apply a layer of grease over it. So what happens is that this layer of paint or oil or grease acts as a barrier, okay, a barrier between moisture and oxygen present in the atmosphere. Okay, so this is how we can prevent corrosion. But the question is, what about the effectiveness of this method? Is it effective? The answer is no. Okay, it's just a temporary solution. Okay, now why is it temporary and how is it temporary? It is temporary because if the paint comes off, if the paint peels off, then what will happen? The metal will be exposed again, and then the exposed metal will start reacting with the moisture and oxygen present in the atmosphere, thereby the metal will undergo corrosion again. That is why this method is temporary. Okay, so is it a better so what should we do then? We should opt for another method. So let's go and visit the second method, which is called the sacrificial protection. Now why is it called sacrificial? I'll tell you later. Now in sacrificial method, if you want to know how it is done, okay, we have a technique called galvanization. Okay, what is galvanization? Galvanization simply is, my dear students, applying a layer of zinc on iron. So once again, my iron is here. So this is iron. Now this time I'll be applying a layer of zinc over it. Okay, I'll be applying a layer of zinc over it. So let's say this hand, okay, my hand is the layer of zinc. Okay, so this is how we will apply. Okay, we'll coat the iron with zinc. Okay, now let's see how it works or how it is done. Okay, so how it works. Okay, the layer of zinc acts as a barrier. Now first of all, this is the metal and my fist, my fingers are the zinc. So what it does is that my hands now they shield or they protect the metal, okay, from the atmospheric oxygen and moisture. So are they not acting as a barrier? Yes, they are acting as a barrier. Okay, so they act as a barrier. Okay, and zinc being more reactive than iron. Okay, zinc is more reactive than iron. Remember this. Okay, in the reactivity series of metal which we have studied, zinc occurs first, okay, at the top. So that makes zinc more reactive than iron. So this is iron and this, my fist, is the zinc. So which is more reactive? Zinc is more reactive than iron. Remember that. And zinc being more reactive than iron oxidizes itself in place of iron. So now, which is more reactive? Metal, iron, or zinc? Zinc is more reactive. So who will get to oxidize first? It will be zinc. Okay, so zinc will oxidize instead of iron. Okay, so iron is safe. Okay, and this is the reason why it is also called as a sacrificial protection, because it was supposed to be iron who should be oxidizing, okay, who should be undergoing corrosion, but no, now because of the presence of a more reactive metal which is zinc, okay, will get to react with oxygen. So zinc gets to oxidize and thereby our metal which is iron is safe. Okay, and this is how galvanization works. Okay, so remember, this is galvanization where we apply a layer of zinc on iron to protect the iron. Okay, now let's talk about its effectiveness. Is it effective? Definitely it's much more effective than barrier protection. So better than barrier protection, but not a permanent solution. But still then, this is not a permanent solution. Okay, so then let's go and study the next one, which is alloying. Okay, so the third one is called alloying. So what is alloying? Alloying is simply a mixing of a metal with a metal or a metal with a non-metal. This is what alloying is. Okay, so let's study in detail. How is it done? So let us take the example of stainless steel. Okay, what is stainless steel? Stainless steel is the same material with which our utensils are made. Okay, at home we are using stainless steel equipments. Our utensils are made of stainless steel. Our plates, okay, some of our plates are made of stainless steel, and some of our cups are also made of stainless steel. Okay, so stainless steel, we use stainless steel. Now stainless steel is an alloy. Okay, my dear students, so stainless steel is an alloy. Since alloy is mixing of a metal with a metal or a metal with a non-metal, so remember, metal plus metal, okay, gives us alloy. Metal with non-metal also gives us an alloy. Okay, so mixing of metal with metal or a metal with non-metal, okay, this is how alloying is done. Now why is alloying done? We do alloying, okay, because so that its properties can be, the properties of the particular metal of interest can be altered. I repeat again, why is alloying done? Alloying is done so that the properties of the metal of interest could be altered. For example, let's take iron. Okay, this is iron, this is our iron, this is iron. Now let me tell you, my dear students, that pure iron is soft. Okay, pure iron is soft, and being soft, okay, it is of not much use to us. Okay, if iron is soft, then we cannot use it for construction, we cannot use it for making wires, or we cannot use it for making any other thing. Okay, being soft, its usage is very low. Okay, so but iron is one of the most widely available mineral. Okay, so and plus it is cheap also, so we want to use iron, but it is soft. So what we will do, we will alter its properties, and in order to alter its properties, alloying is the best technique. Okay, so we will do alloying. So we will try to enhance some properties of iron. Okay, we will try to make it harder, and plus we will want to make the iron stainless, which means it will not undergo corrosion. So can we achieve that? The answer is yes, definitely we can achieve that. How? By the process of alloying. Here is the answer. Okay, alloying is the answer, okay, by which we can alter the property of metal, okay, of the iron metal. So we are going to make stainless steel. So stainless steel is an alloy of iron. So iron is one of the metal. This is the primary metal. Okay, then nickel is also mixed. So another metal called nickel is a metal, is mixed. Okay, now what will this nickel provide? This nickel, okay, naturally being harder than iron, so on mixing nickel with iron, what will it provide? It will provide hardness. Okay, it will provide hardness to the alloy. Okay, so it will provide hardness plus chromium. This is the third metal. Now by default, by natural, chromium is resistance to corrosion. That means it does not undergo corrosion. Okay, so we want this property, okay, which chromium has, to be given to the iron. So what we do is we mix our soft iron, we mix nickel and chromium, and together what we get a new alloy. Okay, we get a new metal, we get a new substance which is called an alloy. So the new substance is an alloy of these three: iron, nickel and chromium, and the new substance will have a mixture of all their properties, enhanced properties, okay, better properties. So we get ourselves stainless steel. All right, so this is how we get stainless steel. Now what about its effectiveness? Is it effective? Yes, it is definitely effective. Okay, so this is a permanent solution. So once an alloy is done, it does not revert back to its original state. Once we get an alloy, it will not go back to being a chromium, or it will not go back to being a nickel, or it will not go back to being a iron, okay, after 10 years or 20 years. No, once an alloy is formed, it will remain an alloy till the end. So it is definitely a permanent solution to fight against corrosion. Okay, so these three techniques which were discussed in your textbook, I have explained. Now in the next we'll discuss about some more alloys. Okay, so let's study about some more alloys. Here are some important alloys which needs to be discussed. All of these alloys have been discussed in your textbook, so let's have a look at them one by one. Okay, so the first one is brass. So brass is an alloy of copper and zinc. Okay, so the composition of brass is copper 80% and zinc 20%. You need to know the composition also. Okay, these things are asked in the exam in the form of MCQs also, so it will be good for you to know. Okay, so I hope you are taking down the notes because these are important for you. Okay, so the properties of brass is malleable. Okay, malleable means the property by which it can be hammered into thin sheets. Okay, like just like aluminium. Okay, aluminium can be hammered into thin sheets, and then we use that thin aluminium foil to wrap, okay, objects so that it can be kept hot for a long period of time, is it not? So malleable, strong, and it resists corrosion. Okay, so brass is corrosion free. Okay, and since it is corrosion free, since it will not undergo corrosion, it is also used for making utensils. Okay, it is used for making utensils like brass pots and brass cups and mugs. Okay, so they are used for making utensils, as well as screws. Okay, screws which you find in your TV, refrigerator and all that. Okay, they are all made from brass, remember that. Next is bronze. Okay, we are all familiar with bronze. Okay, gold metal, silver metal, bronze metal. Okay, so bronze is an alloy of copper and tin. Okay, the composition of copper is 90%, and the percentage of tin is 10%. Okay, then properties of bronze is strong and it resists corrosion. Okay, the bronze medal that you receive during your sports event or for any other event, okay, you will keep it in your room for years and years. Also it will remain like that. Okay, it will not undergo corrosion. Okay, remember that. And then where are we using bronze? They are used for making coins. Okay, and they are also used for making bells. Okay, so the bells that we see in and around us, okay, it may be church bells, temple bell, mosque bells. Okay, the bells that we see around us, they are all made from bronze. Okay, and that is the reason why you will never see a bell okay, getting corroded or getting rusted, because bells are made from alloys, okay, and not from pure metal. Remember that. Next is steel. Very, very important. Okay, steel. So steel is an alloy of iron and carbon and some other metals. Okay, the percentage of iron in steel is 80 to 98%, and carbon is about 0.030 to 1.25%. Okay, now why are we adding carbon to iron? Because we know that pure iron is soft. Okay, and being soft, iron has very few uses. Okay, we want the iron to be hard. Okay, so in order to alter the property of iron and make it hard, we are using carbon. So carbon is used to make it hard. So the property of iron will change. The new property of iron is it is hard and has got high tensile strength. Okay, next, okay, then the uses is construction. Now that iron is hard, okay, we can use it for building homes because it will be able to pick up the load and give us a firm structure. So we use it for construction. So majority of the steel, okay, majority of the steel which is produced in the world is used for building bridges, construction material, okay, whether it's bridge or house or buildings. Most of the steel around the world is used for making construction purposes. Next is solder, okay, not soldier, but it is solder, S-O-L-D-E-R, okay. So solder is an alloy of lead and tin, okay, 50% lead and 50% tin, 50% tin, okay. And the property of solder, okay, lower melting point than lead and tin. So solder has, okay, a much lower melting point than lead and tin. Now having a lower melting point, it is used for joining electrical wires. So whenever there's a break in the connection between two or more joints, we use solder, okay. So say for example your laptop or your computer got shocked, or it got burned, or it got some short circuiting. So what you do is you go to the technician, and then the technician will open the laptop or the computer, and then he will do some inspection using some machine, okay. And once he detects that there's a short circuiting or a wire has been broken, he will use solder to fix it, okay. So it is used for joining electrical wires, okay, remember that. Next, okay, here now amalgam. What is amalgam? An alloy of metal and mercury. An alloy of metal with mercury is called as amalgam. So whenever, okay, whenever alloying with mercury is done, it gets a specific name. It's called amalgam, okay. There are two types of amalgam. We have zinc amalgam and dental amalgam. Zinc amalgam, as the name suggests, okay, it will be zinc plus mercury. So here the alloying is between zinc and mercury. Then what about dental amalgam? Dental amalgam, okay, dental amalgam, it is between the metal here will be silver or gold and mercury. So this is dental amalgam, okay. So well, we are almost at the end of the topic. Now I have one small thing to tell you about gold, okay. So before we end the lesson, let me tell you about that also. So I hope, my dear students, you are taking down this table, okay. If you have not, pause the video and kindly take it, okay. Now coming to the last part, let me just erase this one and tell you about gold, because it is mentioned in your syllabus also. So we are all familiar with gold, but remember this, my dear students, that gold is also an alloy, okay. So gold is an alloy. So gold is also an alloy. Gold is an alloy. You may not have known it earlier, but today you know that gold is an alloy. I'll tell you about gold. So how do we measure the purity of gold? The purity of gold is measured in terms of carat, okay. So purity of gold, nobody would like to buy a impure gold. Everybody would like to buy a pure gold, okay. So purity of gold is measured in carat. So carat, okay, the purity of gold is measured in carat. Now what value of carat will a pure gold have? The value of carat that the pure gold will have is 24 carat, okay. So 24 carat is the value of pure gold. Now remember this, my dear students, that just like iron, pure gold is also soft, and being soft, it cannot be used for making ornament, because in order to make ornament you have to cut, okay. Suppose you are making a necklace, it has to be cut, or you are making a ring, it has to be cut. But since it is soft, okay, the circular ring will deform itself, so it will change in shape, okay. So you will not like it. So gold is soft, and being soft, it cannot be used for making ornament. So what the goldsmiths do is that they will put some impurities. That means they are going to mix some foreign substances into gold. So basically that makes gold an alloy, is it not? So there are, okay, so what the goldsmith will do, the goldsmith will give you 3 varieties of gold. Okay, one gold is called the 22 karat. The other one is called the 18 karat, and finally the 12 karat. So you will be told to choose from these 3. Okay, now 22 karat means it will be 22 parts gold, okay, pure gold, plus 2 parts it will be impurity. Now the impurities, okay, the impurities used here, it will be either silver or it can be copper. So these are the 2 impurities which the goldsmith may use. Okay, he may use silver or he may use copper. Okay, why is he using these impurities? So that the gold can become hard, and once the gold is hardened, you can do engravings or you can cut it. Okay, and you can get the required shape, whatever shape you want it. Gold will we can make the gold into the required shape, for which gold needs to be hard. Okay, so it is to make the gold hard so that ornaments can be made out of it. Okay, so 22 karat gold, okay, 22 parts pure gold plus 2 parts, so together that makes how much? So 22 plus, so 22 plus 2 gives you 24, is not? Okay, so this is your 22 karat gold. Okay, what about 18 karat? 18 karat will be 18 parts gold. Okay, 18 parts gold plus how many? 18, how much will it be? 6 part, na? 6 part impurities. So there are more impurities in 18 karat. Okay, so 18 plus 6 gives you 24. So this also is 24. Okay, by weight it has to be 24. What about 12 karat? 12 karat is 50% pure gold and 50% impurity. So we have 12 parts pure gold and 12 parts of impurities. So exactly 50-50. 12 parts of impurities, because 12 plus 12 gives you 24. So basically in all the 3 variants you are getting by weight. Okay, 24. Okay, and likewise even there is a variation in the price. Okay, if you ask me which will be the expensive, it has to be this 22 karat, because more gold is used here. Okay, likewise below that it will be this, because 18 parts is gold, and finally you will have 12 karat gold, where 12 parts is gold and the remaining 50%, exactly half, is impurity. Okay, and the impurities used here are silver and copper. So that's it. Okay, that is it. The lesson has come to an end, but before I leave you guys, okay, I have a question for you. So I would like you to comment the answer, okay, in the comment box. So do not hesitate, but please participate. Okay, because participation makes it more interesting and more better. So the question for today is, it is from the explanation which we have just concluded. Bronze is an alloy of, you have to tell me. The options are copper plus zinc. Option B, copper plus tin. Option C, is it lead plus tin, or option D, lead plus iron. Okay, so kindly comment the answer in the comment box. I always go through the comments, okay, and then I like the participation that you have been giving to me. So thank you all for participating. And with this, my dear students, the chapter 3, metals and non-metals, has come to an end. The next lesson that I'll be starting will be electricity. So I want you all to tune in and learn again. So until then, okay, you all take good care, and summer vacation is just around the corner, so you also go and have fun. Even me, I'll have fun, but do not forget your duty, which is to study. Okay, so have a good summer vacation. In between, okay, I'll be uploading videos, so do not forget to tune in and watch. Okay, so take good care and God bless you all.